So he is asking evaluate surface integral f dot n cap ds, or we can also tell this as flux across the surface. Okay, so double integral surface f dot nk n cap is also called as flux across the surface. Okay, so where he has given f value is xi plus yj plus zk over the sphere x square plus y square plus z square. So let us see how to do this. So first write given f function is equal to xi plus yj plus zk. Okay, implies if I use Gauss divergence theorem for this, we have to find divergence for it. So divergence of f will be how much? So this one equal to dou by dou x of f1 plus dou by dou y of f2 plus dou by dou z of f3. So this one equal to how much you'll get? Dou by dou x of f1. f1 is nothing but x plus dou by dou y of y plus dou by dou z of z. So what will be the value of divergence of f?
3.
So I'll get 1 plus 1 plus 1, that is 3. Okay. Now, if I apply volume integral on both sides, what happens? Volume divergence f dv is equal to triple integral 3 dv. Okay. So what is this here? So curve is sphere, right?
X.
Okay. So this one is equal to 3 into triple integral 3 dv over a sphere. Okay, so this is nothing but 3 into, okay, so here integrand is not there, only curve he has mentioned, through this sphere he is mentioned. So that means whenever integrand is not there, only dv is there, or dv is nothing but here, you can write precisely. So this one is dx, dy, dz. So dB value is nothing but dx, dy, dz. So integrand is not there, only integral of dy, dx, dy, dz is there. So that means you can write this as volume of the sphere. So whenever you are applying triple integral, so it will be converted into volume of that curve. Okay. So this one is equal to 3 into, so what is the volume of the sphere? You can write directly. It is 4 by 3 pi r cube. Okay. So where r is the radius of the sphere. Okay. So but what is the radius according to the given equation? This is x square plus y square plus z square is equal to a square. Okay. So r is nothing but a. So radius is a. So answer is 4 pi a cube. Fine. So here one more problem based on the same pattern. So the question will be like this. Evaluate surface integral axi plus byj plus czk okay dot n cap ds, okay, where s is the surface of the sphere x square plus y square plus z square is equal to 1. Okay, like this they have given. So it is also in a similar way. You can apply directly volume integral. Just he has asked to evaluate, not to prove, right? So you can apply Gauss divergence theorem. You can convert this surface integral to volume integral and you can evaluate it. So given f is equal to axi plus byj plus czk. Similarly, x square plus y square plus z square is equal to 1. So that means R value is 1. Okay. So implies if you are applying divergence theorem, find divergence of given f. So that means dou by dou x of f1 plus dou by dou y of f2 plus dou by dou z of f3. Okay. So this is nothing but dou by dou x of ax, dou by dou y of by plus dou by dou z of cz. So what will be the divergence?
A plus B plus C.
So we'll get a plus b plus c. Okay. Now we are going to apply volume integral around this. So volume integral divergence f is equal to volume integral a plus b plus c dv. So here I need to write dv. So dx, dy, dz. So this is nothing but triple integral. You can write these constants outside a plus b plus c. Okay. Triple integral dx, dy, dz. Okay. So this is nothing but sphere with radius 1. Okay. So integrand is also not there. So a plus b plus c into volume of sphere. So this is nothing but a plus b plus c into 4 by 3 pi r cube. Okay. So this one is equal to a plus b plus c into 4 pi divided by 3. Okay. Since r value is 1. Fine. So by Gauss divergence theorem, What is it actually? Surface integral S f dot n cap ds is nothing but triple integral divergence f dv. This is v. So this value we got it as 4 pi by 3 into a plus b plus c. Fine. So you have to mention this theorem. Okay, whenever you are using Gauss divergence theorem, so you have to mention this theorem and you have to show. But
Yes, sir.
next, if f vector is equal to 2xy I plus yz square j plus xzk and S is the rectangular parallelopiped okay bounded by x is equal to 0 comma y equal to 0 comma z is equal to 0. Next x equal to 2, y equal to 1, z is equal to 3. Okay, now he is asking find the flux across the given surface. Okay, so solution. First write given f is equal to 2xyi plus yz square j plus xzk. Okay. Now divergence f you find is equal to dou by dou x of f1 plus dou by dou y of f2 plus dou by dou z of f3, where f1, f2, f3 are the quotients of ijk. So dou by dou x 2xy plus dou by dou y yz square plus dou by dou z xz. So this is nothing but 2y plus z square plus x you'll get. So this is the value of divergence f. Now if you apply triple integral on both sides, so triple integral divergence f dv is equal to, so triple integral 2y plus z square plus x. You can follow any order. Okay, so usually will follow dz, dy, dx. So according to this, you have to write the limits. So what are the z limits? 0 to 3 is there. So 0 to 3. Next, y value ranging from 0 to 1. Next, x value ranging from 0 to 2. Okay, according to this, you can apply integration. So if you apply integration, how much you'll get? So this one equal to double integral 0 to 2, 0 to 1. So 2y, integration of 2y is 2yz plus z cube by 3 plus xz, having the limits from 0 to 3, dy dx. Integral 0 to 2, integral 0 to 1. If you apply limits, how much you'll get? 6y plus 27 by 3 plus 3x. dy dx. Integral 0 to 2. So how much you'll get? 6y square by 2 plus here if you cancel it, how much you'll get? 9. So 9y plus 3xy, having the limits from 0 to 1 dx. Integral 0 to 2, if you apply this limit, you'll get first one is 2 1s, 2 3s. So 1 square is 1 plus 9 plus, so this is how much? 3x dx. So this is nothing but integral 0 to 2, 10 plus 3x dx. So this one equal to, how much you'll get? 10x plus 3x square by 2. Limits are from 0 to 2.
Sir, their first value is
Sorry,
3, na, sir,
this
before
is
9.
3. This is 3. So 12 you'll get here. So how much you'll get if you apply? 24 in the first term plus 3 into 4 by 2. Okay, 2 1s, 2 2s. So 3 2 6. So total answer is 30. So therefore, by Gauss divergence theorem, okay, the required flux yes, flux across S is nothing but surface integral f dot n cap ds is nothing but triple integral divergence f dv. So which is nothing but 30. Find the flux across the surface. Find the flux surface across the surface. Yes, given that f is equal to x square minus z square I okay plus 2xyj plus y square z square k. Okay, and S is the surface of the cube. Bounded by x equal to 0, comma x equal to 1. Next y equal to 0, comma y equal to 1. Next z is equal to 0, comma z equal to 1. So take this as homework and try. Similarly, one more problem also is there of similar kind. Here we need to verify Gauss divergence theorem. For f is equal to 4xzi minus y square j plus yzk over the unit curve unit cube over the unit cube. Fine. So what do you mean by unit cube?
All sides are equal to 1.
All sides equal to 1. That means x value ranges from 0 to 1, y value ranges from 0 to 1, and z value also ranges from 0 to 1. Okay, so this much only. Limits are this much only, but you have to prove this by Gauss divergence theorem. We have to verify it, whether it is satisfied surface integral as well as volume integral. Okay, so like this kind of problem it is. We have drawn one cube and did right such kind of problem. I think this kind of problem it is. Okay. This. You have to draw the cube and you have to note the surfaces and apply the limits and write. That's it. Okay, first you find the divergence and find the value of triple integral 0 to 1, 0 to 1, 0 to 1. Next, go for each surface. Total 6 surfaces will be there. So for each surface, you have to find the this one surface area for each surface, and you have to club all those surfaces. Fine. So answers also I'll tell. Let's make a note of that. For this answer should be 3. For this answer should be 3 by 2. Okay, so try to work out this problem.